Yeah, hello. Hello, any reason for it? Hello, class. Hello. Hello. Oma.
So maybe
Could it be due to the change in time?
yeah, I guess yeah.
Okay. I'm actually supposed to leave at 6, but I think I
Then
can manage to
maybe we
leave at.
can maybe we can schedule it for another day if you're busy today.
Okay, that will be fine. What of the rest? Can I get your views on this issue? Patience and the rest. Can I get your views? Patience, Priva. Else we can continue till maybe 6:20 before I leave. Mm. I have to take any decision. I take the decision based on your views. Okay. Good. Let's continue.
Yeah, so we have negative 14, okay, minus 14 over what? Negative 13, okay. So you pick the elements minus the leading coefficient, which is what? Negative 14 over the pivot, which is negative 13, times the value on top of negative 14, which is what? Negative 13, which will give you 0. Then you do same for this one, you come and pick it. So that will be negative 23 minus the multiplier times the value on top of it. Okay, in the pivoting row, which will be negative 10. The same way when you come here, you pick this value and the minus the multiplier times the value on top of it, which is negative 36. Okay, so let's see how it goes. So, yeah, so that is it. So A33 will be negative 33 times the multiplier negative 14 times over negative 13 times negative 10, which will give you negative 159 over 13. Okay. Then finally we have B. Okay, new value for B, blah. That will be negative 51 minus the multiplier times negative 36, and that should give us 159, negative 159 over 13. Okay, good. So once we have achieved, we've obtained our upper triangular matrix. Let me draw that again. Okay. So once we've obtained the upper triangular matrix, we can then rewrite the equations. Okay. We can rewrite it in equation form and use the backward substitution to solve for it, like you were seeing here. Okay, so we've eliminated x in the second equation and eliminated x and y in the third equation, which means we can easily find z from this equation to be what? Z equals to 1. Okay, and then substitute backwardly into the next equation to find y, and then you substitute y and z into the first equation to find what? To find x. Okay, now once again, let me mention whilst you come up with any question that you have. Okay, let me mention that the objective of this course is not to reduce the matrices into echelon form. Okay, this is not an algebra class. Our objective here is to find an algorithm. Okay, is to find an algorithm which we can implement. Okay, using a computer software, solve any given dimension of linear systems. Okay, so at the end of this week's class, you'll be writing a program to that effect. So if you watch some of the videos on YouTube on how the Gaussian elimination technique is done, you will find that along the line the concept of echelon forms, okay, are introduced. But we are not interested in obtaining echelon form of the system. We are interested in the algorithm, the process to solving the system. And then once we obtain the process, we can program. We shall program, let me put it that way, in class as an assignment. Okay, so now let me take some questions from you at this point. Let me take some questions from the class.
Are there any questions on this topic before I move to the new topic? Any questions on pivoting technique? Class, any question on pivoting? Okay. If not, then I'm moving on to the scaled pivoting method. So just give me a minute. Let me project.
Yeah, so like we said on Monday, okay, that the partial pivoting technique, okay, Gaussian pivoting technique is limited, okay, with regards to having a leading coefficient or a pivotal value being equal to what? 0, okay. Once that happens, the program written is going to end up with infinity because the pivots are used in estimating the multipliers. Good. So hence the need for another method, which is the scale pivoting. And we also did mention that the scale pivoting technique, okay, the scale pivoting techniques help us to avoid a minimal value of a pivot, okay. Yeah, because it will always select the optimum value of your LIs, okay. I will say to obtain the LI, what you do is first you find the absolute value of the leading coefficient, okay, divided by the maximum absolute of the maximum value in what? Each row, okay. So for L1 is going to be the leading coefficient in row 1, absolute, over the SI, which is the maximum value in row 1, okay. And then once again you find the absolute value. Very good. Then in our explanations on Monday, we also said that to obtain at any step, okay, to select a pivot, you have to find your LIs, okay. Good. But taking into consideration that our scales S, okay, are only estimated once. The SI, which is the S1, the maximum value in each row, are estimated once, okay. So S1 is 7 here, S2 was 7, S3 is 3, and then S4 is 17, okay. Good. Whereas in the first selection for our optimal LI, okay, we use a coefficient. So this will be 2 for row 1. L1 will be 2 over 4. Okay, L1 is what? 2 over S1, which is 7. Okay, L2 L2 is the leading coefficient, absolute of the leading coefficient, which is 4/7. Okay, L3 is absolute of the leading coefficient, which is 2 over the maximum value there is 3. And then L4 is what? Leading coefficient is what? 6 over what? Over 17. Okay. Now we select the index which maximizes, okay, the Li, and obviously the fraction 2/3, okay, like we said, okay, is the biggest what? Index, okay, which means that row 3 will be the best option, okay, as the pivoting row, which implies that we're going to make use of this first element as the pivot, okay. And we also did mention that the computer didn't need to rearrange the rows, okay, but we needed to rearrange for the purpose, okay, of understanding. So what we did in class, in the previous class, was to bring row 3 to the top, okay. So this is what we did. So we said the initial row 3 was brought to the top, okay. So this is row 3, and then this was row 1, okay. Then we brought row 2 down, okay, and then we had row 4, okay, down here, okay. Then we apply the pivoting formula, okay.